Alrighty, welcome to another session of Pair With Me. Today we're going to be tackling Advent of Code Day 1 for 2025. I'm hoping with the new shortened Advent of Code I might fare a bit better. I normally get to day 10, 12, 13-ish in the past few years is where I've gotten to. And obviously I get busier later in the month, so it's going to work out quite well, I think. I may not do it on the day every day, but yeah. Enough chit-chatting. Let's show the tab with everything in it. I haven't looked ahead of time, so let's actually go through this. Oh, this is... So I think the boring part is going to be looking through this. They've discovered project management. To save, you need to finish decorating the North Pole. Yep, 1 star per thing. Password is locked in a safe. Safe has a dial with only an arrow on it. The dials are 0 through 99. As you turn the dial, it makes small click noises. Contains a sequence of rotations, 1 per line, which tell you how to open the safe. A rotation starts with the L or R, which indicates should be left or right, and then the rotation has a distance. Yep, so it looks like we're just going to be summing a bunch of numbers. So if the dial were pointing at 11, a rotation of R8 would make it, what, 19? Yeah, after that L would make it 0. There's a circle. Left from 0 makes it at 0.99. Turning the dial right from 99, 1 click makes it point at 0. Yeah, okay, so it's mod 100. So if the dial were pointing at 5, a rotation of L10 would make it point at 95. Oh yeah, L10. Yeah, okay, that all makes sense. That's easy. The dial starts pointing at 50. This is our data. Cool. So what I like to do for this is I have a little script that will set up my new day. We can go look at day 0 solve. This will actually just run the code. Obviously it does nothing right now, but close that. We also have this day 1 and we have the spec. I'm not sharing it. I knew I was going to do that at some point. I didn't expect it to be the very first point. But anyways, so I have my class for each day over here. I have my tests on the left, on the right, goodness. And I have this solve RB, which actually just runs it like so. But we have our test.txt, which I will just go and fetch the contents from. So I like to set up the first test. So it says, following all of the things starting at 50, the password in the example is 3. So solve first with the test data should be 3. We'll put a pending. I should add pending to the template. I'll do that later. So if I run this, why are you not recognizing as a spec? I swear this was working last time I tried this, literally early. Anyways, we can just bundle exec rspec day 01, day 01 spec. It's just annoying. There we go. Should have gotten 3, got 0. So we go to our solver, which this file might get renamed at some point. My mouse is, of course, on screen. Oh, and before I forget, I will actually go and fetch my puzzle input, which I actually... Something I've learned, and you can't see this, I'm doing save page as, and I'm going to call it, what do I call it? Input.txt? Yeah. And now I can mv tilde desktop input to dot. Yeah. And you can see that input.txt, I put it in the wrong spot. Because yeah, okay, mv input to day 1. There we go. Day 1 input. There we go. So we have our 4100 odd lines. I don't really care. Test.txt, we don't even need to keep open. We keep this open. So let's start with describe, like a type, hash initialize, do end. So it starts at 50. No, sorry, it starts at 50. So expect this is at solver.load. So if we do solver equals solver.new, expect solver.password.to equal 50. So our very first test. Oh, I do parse data on that, don't I? Ugh. And I can't... Not being able to run my spec is actually really annoying. There we go, so I don't get that thing. I don't know why that's not working all of a sudden. It's named correctly. It's underscore spec.rb. It's in a Ruby folder. I don't know. I'll just accept that it's broken for right now. So obviously we just do at password equals 50. We add a reader password. Oh, it doesn't matter. I have to run like that. Oh, I haven't passed anything in. Because it should parse data, right? Solver load. Okay, we can just do at solver, because all parse does is actually... There we go. So we have a parsing test. So the way I structure this is I have a load method which you just call on it, which takes a file path. That reads it into the new method, which is read as data, which is just parsed into some sort of shape ready to be handled by solve first and solve second. So parse is usually where the interesting stuff happens. I make it private just because I don't test it directly. Solve first should return 3, but at data is going to be each, we'll do the lines.map. We can make this something nice. Do line end. We are going to return, I think, just a set of numbers, like L is minus 68, R is nothing. We could do this dodgily or easily. Let's do it in a way that isn't super gross. Yeah, because I could have G-subbed. God, I don't like that. Yeah, let's... This is a bit dodgy, but this is what I love about Ruby. We can G-sub, and we want L to be... So left is minus. And we want to G-sub the result of that with R into nothing. And standard RB will fix that for me into like a delete, I believe. And then we can just map to I. And then we should actually see that by P at data. And we run our tests. Oh, G-sub for instance of array. Oh, yeah, right. Dot. And then I do dot lines on the end of the G-sub. There we go. So this is a bit... I tend to code golf, not code golf. I tend to write less than amazing code here. But yeah, as you can see, I'm getting an array with all of the correct numbers up here. So that's really good. And that means we can just... Solve first is going to be... So if it's a negative number, we just need to keep adding 100 until it's... Hang on, I forget something. If I have... Gosh, A equals 10, B equals 3, A mod 3 is 1, because there's 1 left over. But if... I did A mod 3. If A is minus 10, what is A mod 3? It's 2. Does that give me the right number? No, because I need to... Yeah, so modulo won't help here for the negative case, which is fine. So we want at data.sum, and we always pass it as 0, just in case data was empty. We still get a 0 back. That's good practice. We should get something that's probably wrong. This, I hope, will fail the test, because I haven't handled... Yeah, minus 218. That's wrong. Oh, so, and yeah, at password plus data.sum. I get the mouse out of the way, Sean. Come on. Minus 168 is still way off, because the expected answer is 3. Hang on. I'm going to share Firefox again. Did that? Yeah, there it is. So I'm looking at this. The dial starts at pointing at 50. Yeah, so left 68. Oh, I have R and L backwards, do I? Left would cause it to point at 95. No, because left minus. So hang on. The dial starts pointing at 50. The dial is rotated left 68, leaving it pointing at 82. Left 30 is minus 30. Oh, yeah, no, okay, I'm not thinking straight. Yeah, okay, that's a little more annoying. Yeah, okay, so what we can do is, yeah, so... Oh, I still have the Firefox up. Oh, Jesus. This is terrible. This is why I didn't want to, like, do browsers and stuff. Okay, so 68 is 82, that's correct. Minus 30 is 52, which is correct. 48 is 0. 5 is 95. Yeah. 60 is 55. Yeah. 55 is 0. Yeah. 1. Minus 1 is 99. Yeah. Minus 99 is 0. Yeah. 14 is 14. 82 is 32. Because the dial points at 0. Oh! The number of times the dial is left pointing at 0 after any rotation is the actual password. Is the actual count. Right, so password becomes count. At password equals 0. We need to fix our tests. At count equals 0. At password is 0. We need to... Gosh. This is a mess of a video. Hopefully they get a little better, eh? Right. Dun, dun. Yeah. If at password equals 0, at count plus equals 1, and return at count. Alrighty. Got 50. Oh, right, I've got count and password backwards here. Password, you are count. Yep. And this is password and password. There we go. Hey, part 1 is solved. Assuming we don't ever have, like, if we can just look at the, I didn't save this. And I've now opened it up twice. Beautiful. Going swimmingly, isn't it? Input. At a very brief glance, it doesn't look like there's anything over 2 numbers. So let's just assume that that's good, and we can run this. So 401 is our answer. I'll share Firefox so you get to see this. 401. Submit. Too low. Interesting. Huh. Why is it too low? We passed the test. Let's switch back to code and let's have a look. There's Neovite. I haven't drunk my tea yet. There we go. I didn't start any music. Oh my gosh. Alrighty. Oh, this is becoming a mess. So what could be going wrong? Ah, there it is, 745. Okay, it's exactly what I thought it was going to be. That's fine. So we can actually, something I like to do now that we've identified a problem is let's add a spec for it, right? Gosh. Test txt. The easiest way to test this. How do I want to structure this? I think it's just kind of parse data, right? Like if we calculate this, what do I want to do? So until at count dot between 0. No, is between inclusive in Ruby? Let's find out. IRB 1 dot between. I forgot the 199. True, and yeah, and obviously 101 is not between. Okay, sweet. So until count is between these two numbers, loop. Cool. I didn't add the question mark, and I was trying to run the tests. This is going messy, but you know, that's life. All right, our tests still pass. That means our code didn't break anything. Let's try actual solve. Okay, 1007. That sounds... Oop. I'll share Firefox with you so you get to enjoy the submission. There we go, part 2. Right. You sure that's the right password? Won't open. Yep. Something always goes wrong. You're rolling the snowballs for your snowman. Please use the password method. That looks like hexadecimal. Means you're supposed to actually count the number of times any click. Okay, so if we've gone... Okay, this is really easy. Dial starts pointing at 50. Yeah, so our test for data would become 6. So this is no longer pending, and we want to do 6 control A. And we should have, not solve, spec. There we go, we got 0. So I'm going to be pretty lazy. I actually think this is going to be... This is kind of dodgy. I think we can just do this. Oh my god, I'm not showing Vim. I don't like this setup. Tomorrow I am absolutely not showing Advent of Code. I might just copy and paste things into a markdown file because I'm sick of screwing this up. It's dumb. Alrighty, so what I've done is I've copy and pasted the solve first into solve second. I've set up the spec to take the numbers, expect the number 6 out of it. And every time we go over this, we know we've gone past 0. So we just add onto the password. And it should work for, if you're like 700, it should add 7 because it has to do it a bunch of times. So now I can run the specs. I got 9. Interesting. Why did I get 9? Why did I get 9? Password plus equals 1. Password. So yeah. So if we are already between 0 and 99, I don't think we even enter here, do we? I don't think so. Let's start doing some debugging. Puts, count, and that's an at, and that's a thing. Datum, that's not an at. Alrighty, and we go puts under 0, puts above 99. I'm holding shift. And puts landed on 0. Alrighty. So if we now run our spec with just 26, so we only do our solve second, let's have a look. Oh, that was crap. Puts password at password. Right, alrighty, this should give us everything we need to know. So, 18, yep, under 0, so yes, correct? Wait, why is count minus 18? Why is count minus 18? Count should start at 50. That's solver.solve, yeah. Puts at solver.password. Fingers, please. Count? What's happening here? Yeah, 50 and 0. Oh, datum's minus 61, so under 0. So, yep, we get 1. 52, yep, we stay at 0. We add 100. So we're at 100 exactly. Above 99 landed on 0. Count is 100. Oh, okay. Goodness. So if we are above or below and we... Oh, God. What's the nice way of doing this? I feel like I'm brute forcing this in a weird way. Because I could do something silly like you added to password equals false. And here we added to password equals true in these. And not added to password. I think that works. 8. That removed one of them? Okay. Hang on. Once. In this example, the dial points at 0 3 times at the end, plus 3 more times during a rotation, so it would be 6. Let's go through and see where we differ from them. Right, first one is count minus 18, so we have... It points at it once. Yeah. Count 52. Yeah. Then R48. Yeah, so we get 2. Because R48 is rotated to point at 0, so correct. And they say L5. Oh. Because we were on 0. That's tricky. Okay, so we're getting issues because we're counting when we were on 0. So at 0 equals at count equals dot 0. Right, goodness. Unless at 0. Whoops. But is this... No, hang on. I think that doesn't work. I feel like I've done this a really silly way. Can I step back? Can I just reconsider entirely what I'm doing here? So... if I just add up all of the numbers, do this check right at the end? No, I don't think that'll tell me, because if I flick back and forth across 0 a bunch of times, that won't be caught. We need to do it per loop. Let's throw this in the bin. Let's just chuck that for a second. Let's shelve that. So we have a datum. So we know we need to do at count plus equals datum. That has to be done. That shifts the needle. So we've done that. What do I want to do here? I'm not loving this answer. This is the longest a day 1 has ever taken me. I normally knock them out in like 5 minutes because it's like sum 6 numbers and move on your day. This is fun. I like these brain teasers. I'm also doing this straight after work, which doesn't help. And count plus equals datum. So we need to handle all of our cases. So we know if at count equals 0, we want at password to plus equals 1. That's obvious. But it's also how many times did we loop through 0 to get here? So we could just check if datum is larger than 100 or minus 100, but that's kind of gross. Although, hang on. IRB. So if oh god, if we do 100 modulo 197, we just get, 197 modulo 100. I always get that backwards. We get 97. But if we do, we get 3. Is that correct? Is that what we want? Am I doing this right way? What's 3 modulo 10? Yeah, it's 10 modulo 3 gives us 1, which is what I want. Yeah, so if I do 100 modulo 97, I get 3. I feel like I'm missing something really obvious here. Oop. What's 100 modulo minus 97? It's minus 94. Alright. I feel like my brain isn't clicking modulo well enough right this second. How many times does 100 go into thing, right? Gosh. I know I use it for FizzBuzz, but it's been a minute since I've done a FizzBuzz. Wait, 100 modulo 19... Hang on. Let's do something fun. No, that doesn't work. No. So if we have our count... Alright. I'm doing my brain in. I really shouldn't do this straight after work. This has gone abysmally. I'm leaving Firefox up. I'm doing all this goofy stuff. I'm leaving my mouse in the middle of the screen. Right, what do we got? So we do want to check... Let's do it the really easy way. If at count... Oh, yeah, if... Oh, hang on here. Hang on. If datum... greater than 100... greater than or equal to 100... I think there's still edge cases, but I think this gets us a lot closer. Oh, hang on. Alrighty. I'm back. I think I'm going to do the really gross thing. I think I'm going to implement this in an incredibly brute force, physical world way, where I actually just iterate over these things and count the zeros we hit. I think that's kind of funny. So what we can do is we can just create a new class called dial and describe dial. So what I might do is I might re-implement the first one as well. Oh no, this won't work because it's only when it ends on 0. We can track both. That's fine. Describe dial do, and this is fine. Initializes at 50. Yeah, describe hash initialize. It starts the count at 50. Do end. It starts the password at 0. Do end. And we do dial.new.count. Oh, dot equal 50. Come on, fingers, goodness. gracious. Do that. Password to equal 0. I really feel like this thing, the show keys thing, should probably clear out a bit quicker, but it is what it is. Beautiful. I still don't have this. That is so annoying. Colon 33. Kablamo? What syntax did I mess up? Style end? What? Describe do? Unexpected, assuming there's a closing the parent. Oh. This. Let's delete that. There we go. I just left bad code in. Yep. Undefined, undefined. Absolutely understandable. This will have an add a reader of dial at dial equals dial.new, but we don't know that yet. Bonk def initialize and add a reader. Whoop. Count and password. That should now pass. It does. Beautiful. Describe hash increment. Do end. So I want it to. Yeah, I think we can do this. I think this is fine. We're just going to track the password separately for part 1. And part 2 will just use the internal password. So it increments the password if, yeah, saying up to end context increments to 0. It increments the password, yep. So I just want this to be an adder accessor, don't I? Oh, let's just do this. That makes it a bit easier. Makes it more testable without having to be dodgy. Bind new password 99. Dial equals, and we do dial.increment. So here we expect dial.password not to equal 0. And then we can dial.increment, and then it equals 1. Yes, and it resets the count to 0. Oh, password is not 99. Come on, Sean. Count. Count. My Australian's coming out in me. Dial.increment, and yeah, count is 99. Count is equal to 0. There we go. It should do none of those things because that method doesn't exist. Excellent. Yep. So we just do this. So at count plus equals 1. I know this is a really brute force, non-mathematical way to do this, but I think that's a bit of fun. Like, I like these sorts of this is how I solve real world problems. I treat them as though they're the real thing and step through them instead of... And once I hit walls with that approach, I tend to optimize. Like, this is easier to ration about, easier to read, easier to, like, structure. If at count greater than equals 100, at count equals 0, at password plus equals 1. And extra junk because I am typing like a weirdo. Expected 1 got 0? Hang on, what? Where was that? So 46. Expected 1 got 0. 46. Yeah, 46. 951. That's... Expected 1 got 0. Dial is 99. Password dial.increment. Count plus equals... Yeah? Yeah? Hang on. Expected 0 got 99. Is this not actually adding to the count at count? I've spelled it all correctly. If count is equal to 100, at count's 0 and at pass. Let's, hang on, something weird is happening here. What's happening? Oh, I just didn't save the file. Okay. That's me. We also have a decrement. Decrements to 99. Increments the password though. So if we're at... If we're at 1, we'll decrement, we'll hit 0, but we won't jump. So decrements to 99 is 0. Yeah, resets the counter. Okay, hang on. Whoops. It's 99. So 0, 0, S99, decrement. So that one's correct. This context can go down here. We'll have another end. Decrements to 0. It increments the password. Yeah, so if it's 1 and we decrement, that's what we get. Oh, this should be decrement. Cool. This will obviously fail because it doesn't exist as a method. We can just flog this one. Decrement minus equals. If it is equal to -1, count is equal to 99, and password goes up. Expected 1 got 0. Save the file. What one failed? Spec 71. Decrements to 0 increments the password. Oh, right, yeah. If at count dot 0 at password plus equals 1. Right, yeah. This means we can drop that, and I need to fix that. Yeah, okay, so they are implemented slightly differently. There we go. Our tests work. We should now be able to run this whole file, and yep, we get a bunch of failures. That's correct. Initialize creates a dial at solver.dial to be a dial. I tend to like these really basic specs. I think they're not massive value, but they're easy enough to just create. Delete, pending. But we do expect the other one to pass. So let's do it. So we have our dial. We have our data. So at data.each do datum and what are we doing? If datum.positive at dial.increment datum.times do this. Else, I think it's just abs.decrement. I think that works. And then we want to, so after each one, yeah. So we do, I need to store the count. Count equals 0. Oh, sorry, not count. Password, because this one's calculated differently. Password plus equals 1 if at dial.count.0. And I should add that. And then we just return password. Does that work? Yeah, there we go. Excellent. It's doing exactly what I thought. It's way easier to ration about. It's not like a super efficient solver, but like, yeah, I'm not too fussed about that. And then we just steal this, stick it in solve second. Let's just delete all of this stuff. Blonk. Get rid of that, and then we just do @dial.password. It passes. Excellent. Solve. We get the correct answer for the other one. All right. I'll share this screen and let's see if I've done it correctly. So we should have 11603. 11603. It's too high. Interesting. If you're stuck, make sure you're... 1-1. Yeah, that is substantially higher than the 1000. Have I missed a thing like if it rotates 600 times, we don't increment it? You remember from the training that method means you're actually supposed to count the number of times. Any click causes the dial to point at 0 during a rotation or at the end of one. Yeah. Point at the dial 0 3 times. Hang on. Oh, this is that silly thing where I haven't like... Yeah, okay, I know what this is. I make this mistake every year. I don't reset the solver between 1 and 2. So it's... That dial kept the old count. So it's like 1000 higher than it should be. Now if I run this... Yeah, it's 5820. Why is it... How did they get an extra 1000? Hang on. You know what? I believe it. 5820. I think that was my silly mistake. I don't know why it was so much higher. Oh, I know it was... Yeah, because it was doubled. Because of, I ran it twice. Right, so submit. Ta-da! With that, we've finished day 1. Let's pop this back. Okay, intro. Cool. We've done star 1 and we have done star 2, or silver and gold star I should call them. But yeah, thanks for watching. That was a lot of fun. I'm definitely disappointed in my performance here today. I feel like I should have solved that a lot quicker, a lot easier. I think I came into this tired. I think I came into it, you know, just after a day of work. I think I should have taken like a half-hour break, reset. I should have sat down and thought about my implementation a bit more before I attacked it. But yeah, like it's come up pretty clean. Let's just clean up the old code. Like realistically, this is very easy to ration about. I'm pretty happy with the code itself and how it turned out. Obviously, this code is slow in that it would run incredibly slowly. Like, how long did my solve take? It ran at 300 milliseconds. A lot of that is bundle exec. Yeah, 152. So it's you know, a 0.03. Yeah, it's like 2 frames on a 60 hertz monitor. So it's pretty slow. Mathematically, you could do this, I'm sure, with Modulo. My brain just wasn't having it. I know it's possible to do much simpler, much more optimal, but yeah, I'm pretty happy with that. I'm happy to consider that a success for day 1. And yeah, thanks for watching. Stay hydrated and have fun out there. Bye.